are L.U. Durbar from leading university Sylhet, Bangladesh. Now let's have a look how relentlessly we have worked for our upcoming Rover Challenge 2018.
In this video, design and implementation of our Mars rover has been shown as well as discussed. Our research and development team has drawn a sketch in Google SketchUp first. We have used our own upgraded rocker mechanism into the rover so that the rover can move along any rough places like muddy, rocky and sandy. Now in safety system, for wheels we have used PVC pipes which are really lightweight to go through muddy, sandy and rocky surfaces easily. Motors are secured inside the wheels so that they don't get damaged when they hit by any hard surface. PVC pipes were first cut into small pieces which was 8 cm in diameter and 7 cm in width. Stainless steel were used to make tire frame. Rubber gripper were also used to get better traction while moving the tires. To make sure our rover's electronic devices didn't receive any high voltage, we have used buck converter that converts DC to DC by stepping down voltage without damaging any parts. We have used copper wire in our rover which transfers energy faster without causing any wire heat up. It is also durable and very flexible. We have used RF controller which is later converted into Wi-Fi because RF controllers are very organized and easy to use. In our rover, we applied simple modification of classical rocker mechanism so that it can be implemented easily and we get more accurate mass and force balance. We haven't used any hydraulic suspension in our rover, but the back wheels are systemized to use spring suspension if needed. The rocker mechanism can take any load in any corner of the rover and transmit the whole load in the body by diminishing the effect of that particular load so that we get better traction control. It can easily climb slopes, stairs and traverse through rough terrain. Even in a few feet of free fall, it can perfectly maintain its balance. The rover has been engineered with a bar differential mechanism which ensures maximum stability and dynamic load distribution on all 6 wheels at any given time. This ensures that the rover is able to take on challenged terrain with relative ease. We are using stainless steel to fabricate the arm and the frame of the rover to make it more light, flexible and stronger. Our mast shaft has high fragile strength in case of fluctuating load. We have made our robot arm with stainless steel and aluminum so that it's light in weight. The arms were being made following the excavator so that it can complete multiple tasks. It can lift or manipulate any object comfortably from the base. The whole arm has 5 degrees of freedom and the base can turn around 360 degrees of rotation, which enables us to access the X, Y and Z axis simultaneously. High torque, low arm actuators has been implemented on the rover arm. The actuators we have used in rover are 25 cm and 15 cm of stroke length and can lift minimum 10 kg of weight. We are using 2 isolated bands for communication. We will also be using 5 GHz and 2.4 GHz band and a 13 dBi anti-directional antenna and a Wi-Fi router in rover and an 11 dBi CP antenna in the base station. We have used 3 3-cell lithium polymer batteries of 11.1 volt each. The entire power distribution was constructed in a symmetric way to maintain balance of load. Multiple 360 degrees IP camera were used to get the position of rover and to operate smoothly. High performance and reliable motor driver were used to drive the high torque motors of the rover. As the rover's claw was made to do multiple tasks, it can easily open both its knob on or off the switch. The rover's hand is also capable of pulling the trolley or any cart like that. For autonomous tasks, image processing and GPS are used to avoid obstacles and target identification. Our rover is also capable of extracting samples from depth of 10 cm of the soil and collect it for the science task. Kill switch mechanism is also used for any emergency case. It can automatically turn off the rover in case of the fire or any failure in the system. For science task, we are going to do basic tests of collected samples in rotating on-board device where all scientific tests will be done. All this data will be displayed on an LCD display in base station. From this part of Bangladesh, we plan to compete this year. As we have secured the second place in our first Mars rover competition, which was held in VIT University, India this year, we are looking forward to reach a new milestone and show our ability to world by creating a successful chapter for L.U. Durbar.